Good afternoon, everybody. This is Data Science class, second year, DSC2103. Today we'll be talking about data transformations, and I'll be working using a tutorial script to help you answer some of the questions about a particular data file. Remember to first correctly set up your working directory when in R and install the particular packages such as tidyverse, NYC flights 13, and remember to call up those libraries. So the first thing you want to do is to explore the data set, which is NYC flights. Once you explore it, you can see there's certain information about it, what it includes. If you look here in the window, the help window, you can see that it's a file about flights, in particular airports within 2013, and then it's also showing you years, months, departure times, and arrival times. To better view this file, this is the script you use, and that should be able to open it up right here in your console window at the bottom. So it's quite a big file. It will take some time to open. It's got a lot of data. So you just give it some time to load up. And as we wait, I did receive your assignments for assignment 1, your group assignments. I will be placing the marking guide on the Moodle on Friday. Unfortunately, right now I'm at a conference in Italy and completely within a 2-hour time difference. So it was not possible for me to make the online class. However, your grades will be put on the Moodle by Saturday. So as the file still loads, we can still go through this other portion to see what it entails. I expect that with this tutorial script, this should also help you be able to look at other data types like the one we had provided last week on coffee. So you can see that the flights file is opening, another window, and you can tell that they're from different months, different days. It's quite a big data sheet. So going back to the script, we're going to be using DeepLearn as the package, and that's why you have to have it loaded. And this package, you will see, will help you do particular transformations that you want to do with your data sheet, filtering particular aspects within the data, especially when you're dealing with very big data. You sometimes want to sort it and filter and look at particular patterns that you can try to find in order to help you decide what type of statistical pipelines you're going to be using. So the first portion we're going to look at is filtering of rows. So for instance, if one wants to filter, and the question would be here, you want to see all the flights that happened on the 1st of January, you could then use the script filter the actual data file name, and then the month, which is January, so that would be 1, and the day, which is the 1st. So you use the double equal sign to make it an exact, rather than using just one equal sign, which will give you an error. So when you filter that, you then get results here at the bottom, showing you only those particular flights, but only for the 1st day of January. In order to save that output so that you can have it as a file that you can later save, you then can call it a particular name, like in this case, I've called it Jan1, equal to, you can either use the less than and minus sign or equal to sign. I prefer to use this particular way so that it doesn't confuse me with when I have equal signs within this, the code. And so calling up this will give you a file up here in the global environment that's called Jan1. And if you can see that it has 842 observations with 19 variables rather. And so I can even still open it up within the viewing window up here so that I can only see the filtered data for that particular time frame. And then that is the data that I can go on to analyze, like you were doing when you were when you had the script tutorial with Mr. Bagaga on data visualization. All right, so another important aspect when filtering the data is innately to note that innately R has its own mathematical functions. As we all know, then the equal sign, the greater than, less than sign, and so on. And that includes also the addition, subtraction, the usual mathematical functions. But it's important to know how to use them in order to filter, in order to transform your data. So for instance, if you see the exclamation point equals to, exclamation point implies not. So when you put it before the equals to sign, then it says you're implying that you want something that's not equal to. But when you use the double equal sign, you're saying something that's equal to, okay? However, if I could try this example where I'm saying the square root of 2 squared is equal to 2, this will return a false result, as can be seen down here, because the square root of 2 is a 1 point something, something, so many other decimal points. And usually R tends to cut off the number of other decimal places. So it could stop at 1.4.1, meaning that in that case, the square root of 2 squared will not equal to the 2 as you're expecting it to. So it's important in this case to use Boolean operators, things like the near example, as is seen in this portion of the code. And this is because this then nears it closer to the 2, forcing R to then round off to 2. So if you run that script, then it tells you that is true for that calculation. So if we can use this example Boolean operators to deal with a data file on flights. So if, for instance, you want to see select flights that departed in November and December, or December rather, you could use the filter option still, select your data file flights, and then the month is equal to 1st November, which is the 11th month. And then you use the dash separator, and which will then work as an OR. Then you can put in your 12th month, which is December. When you run this script, your result then gives you the particular November, December flight schedules. And if we could see it in another file over here in the global environment, could open that wider. Okay, just close this off. So the file has been named November, December, and if I could open it up, we within another window, you get to view your flight schedules that only happened within the 11th and the 12th month. So it's quite a big one as well. As you can see, it has 55,000 observations. So it's quite huge, but you get the gist of what is happening in that case with the importance of the Boolean functions. So this can also be used to answer many other questions. For instance, if you want to, because it's such a big data file, you want to see which flights were delayed, which flights have missing data, and so on. In this case, for instance, you're looking at which flights are delayed, were not delayed on arrival or departure by more than 2 hours. And as we can see over here, we use the filter again function. But then in this case, we're using the exclamation point because that represents not, which clearly here the question was which are not delayed. So you have to remember to know where each one of those variables are and how they are listed within the columns of the flight section. And looking at this, you can see that the arrival delay variable is in column 9. So then it's labeled that way, and you want to see that they're not more than 2 hours or not delayed by more than 2 hours. So then you use the greater than sign, which is mathematical. And again, using the Boolean sign so that you can have the either or. And when you run this script, you should essentially have your result that way, which can then again be saved in a file that's now called delay. And if we look over here within the global environment, we can see that that delay flight has, a file rather has so many observations, 316, and has all the 19 variables because you haven't selected or filtered out any of those variables yet. All right. It's also important whenever you're dealing with your data sheets, especially big data sets, you want to see that there are no missing bits because perhaps whoever was collecting the data, if it's yourself, there could be rows and columns that you failed to put information for, either because it wasn't available or because you forgot. So before you get to visually inspect and generate all your graphs and all your statistics and general descriptive statistics, you want to see if there's any missing data. So in this case, the function is that is used is the is.na, and then you list the data file in question. So I want to have that output saved as DF so that I can see what is missing. So if I look over here in the global environment, I have the DF and it says it's quite a large matrix, about 25.6. So I'm not going to bother opening it, although you can still go on and do that when you're going through the tutorial to see what it has picked out as missing data. So the portions that it will pick out as missing data will have, as opposed to having false, will have true in those rows or in those columns. That's when you will know which bits have missing data. So there are some questions here to help you practice on this data file. I'm hoping that you can go through them on Thursday and help you figure out how to play around with the different functions. The next portion is just basic rearranging of your data file, because sometimes it may not be in the right order. Maybe you may be exporting your data from one particular software, maybe you're taking it from Excel in here, and you want certain things to be transformed about you want to add maybe more columns and so on. So these are the aspects about rearranging. And with the changing of the rows, we use the arrange function. So in this case, you use arrange, you put your data file, which is flights. And here we want to arrange it in an order that it is year, month, day, okay? So reordering those rows of year, month, day. So can do that, run it. And so now you have year, month, day listed down there. But you can also use the description brackets function to reorder columns like in a particular order. So you want them in a descending order, maybe alphabetically, or an ascending order. That's when you can use the description function, which in this case we are rearranging departure delay time. So that gets moved about. And then also you can select particular columns. So for instance, you might only be interested in data in particular columns because it answers a particular question for you, and you don't want to handle all the data at once because it's so much. You want to answer your questions in bite-sized portions, like we're talking about with the research question. You have objectives. So then you want to answer every one of those objectives in piecemeals. You get to select those particular columns, and you get to select the particular rows in question that you only want to deal with. So that is done using the select function over here. Please play around with this and get comfortable with it. There is then also the renaming of variables. But this is all rarely used, as you'll see here, because select would imply that you'd have to first select the column before you can go on to rename the column. But sometimes, you know, most times people use their Excel data sheet to do the renaming, but it's just another extra additional thing to know, just in case you don't want to spend that longer time renaming within Excel. So you can also use select to bring a combination of different variables within the columns and move them about within the sheet. So in this case, there is a selection of columns, flights, time, hour, airtime, and everything after that, right? And it's being rearranged around, or it's being just selected for that particular portion. So you can select it and decide that those are the only variables or only columns that you want to work on and you want to analyze using, say, the visual script. So it's also possible for you to add variables using the mutate function. So variables would then be the columns, remember that. So you might have gotten new information that you're trying to use, or you might have decided to now group your observations into particular populations based on what is of interest for you to answer a particular research question. So we can do that using the mutate function. So in this case, you have the flights data set, and you want to select it, okay, first, and you want to select particular variables within it. In this case, variables year to day. Okay, remember the colon implies from one variable end to the other stop variable. And here you are looking for those that end with delay and the distance and airtime. And you want to call this into a different file. So let's run the script and see what we get. So if we look over here, we've only selected these 7 variables, okay, which are flights, year, today, ends with, and so on. Everything that has the delays, the distance, and airtime, which are only 7 variables. So you've apportioned the data set here into tiny bits that you can then analyze that way. And then also, you can then now decide to that particular subset of data, you want to add particular columns because maybe you want to add a different kind of population to it, or a different kind of criteria that you want to handle. So in this case, there's an addition example of a column called gain and a column called speed, okay? And in which case, gain is calculated as departure delay minus arrival delay, and speed is calculated as distance over airtime times the time frame 60 seconds, okay? So you can generate that new file, call it maybe flights SML2, muted to add to the subselected, subset of data, which was flights SML over here, which you first generated up here. And you want to add to it a column called gain, or a variable called gain, which should include, so in this case, you see how the equal sign works, should equal to the departure delay minus the arrival delay. And then the comma is to give you for the speed, which is distance over airtime times 60. So let's run this script and see what we get. So we can see over here, we have in the environments, we can see we have the flights SML2, other subset, okay? I'd just like to see if that extra columns have been added. All right, there we go. So you can see we have the first 7 variables from year to airtime. And over here, we can see that we've had the addition of the gain and speed. Okay, so it's very easy to do your calculations in there, tally up certain pieces of information without having to do them in Excel, where you have so much data and it's going to take a very long time. Okay, so, and you can still continuously add more columns, again, using the mutate function. I'll let you guys play around with that. However, remember that just because you've added them doesn't mean they're going to permanently stay, these columns. So if you want them to keep within the data sheet, you then use the transmutate or transmute rather function, and this will help them to permanently, your new columns to permanently stay there, so that when you save your outputs, they have those new addition variables. Then it's also possible to group your data using the summarize function. And you can group anything. In this case, there is grouping of, okay, if we can look here, we can apply the a summary of the mean departure delay time, okay? And we also want to exclude those that have missing data because they would not be informative. You have used the summarized function in the last descriptive statistics script. So if we run this script over here, okay, so it summarizes for us the mean departure delay time, which is about 12.6 hours. And then we'll notice that summarize is not very helpful, so it has to always be placed together with group by. And in order for you, because it will only get the average delay time, but if you use the group by, then you can get it by the particular day and by the particular date to understand for each day or for each month, how much delay time was there on the flights. So for instance, in this case, we want to see the delay for each day in per year, per month, okay? So we use the group by function over here if we run that script, okay? And we will then see the generated output, which is called by day, has all the 19 variables, and it's showing you the delay time going to be, this will take long to open, so I will let you guys play around with that in your own time. All right. Then also don't forget to summarize that. Okay, so when you summarize that, it will give you the average delay time by day, by month. If you can see the output here at the bottom. Say for instance, 2013, in the first month, the first day, the delay time on average is 11.5 hours, and so on and so forth. And there are so many other rows, as you can see, with 355 more rows. So perhaps you can play around with it, save this output from the delay by day, right? So that you can see it over here in your global environment, and you can be able to open it in your spare time and really understand your information that is generated. So you can see data transformation manipulation is a very easy way to get particular quick pieces of information about your data to quickly answer some of your research questions. So it's also possible to combine your codes using what are called pipes. And this helps, execute so many jobs at one time, but it does have an order about it. It's not something that you just throw together. It's important that you first understand all of your codes beforehand before you go into piping. And also be very careful how you arrange them, where you put your comments and so on and so forth. I find that when the code is too long, like in this case, it's quite too long, I don't write it all the way out horizontally. I get to the comma points and I make breakpoints in there by using the enter sign, the enter on keyboard. So, for instance here, we want to group these flights by a particular destination, and we run this script, and we want the output file to be called by DST or by destination. So we're grouping the flights by destination. If we look at the output, it's quite big, but essentially it does group them by a particular destination. So notice here that the grouping by destination is a generation of populations, right? From your observation points. Because in this case, you want to answer a particular question, and I think the question here would then be, what flights make it to particular areas, which flights go to New York, which flights go to Hawaii, and so on and so forth. And you want to get information on how much delay time there is for flights that make those particular destinations. So once you have grouped them for your particular question, and you want to summarize particular stats about it, you want to get your distance, you want to get your average arrival delay, you want to get your number of flights, okay? So you can generate a file with the name delay for your output, and using the function summarize, you want to know by destination, you want to know, you want to count the number of flights, you want to count the distance, but also removing your missing data, and you want to also look at the delay times, again, removing any missing data. So if we run this, okay. So in the environment, we now have the output delay, and delay is showing us 105 observations. I think this is small enough for us to open. Let's look at it. Okay, here it's opening. Okay, so if we look at delay, we can see the particular destination. There's Albuquerque, there's Alabama, and so on. Please read the file structure to know what all these destinations are. It's not important that you keep them in your head. You're not going to be examined on them. It's just for your interest's sake. And then you can see the number of flights. You can see the distance flown there. You can see the number of hours of delays in flights. You can see here, very interestingly, there are no delays. It's in negative. It's showing you that for that particular destination, flights were always earlier than they were meant to get there. So those are very interesting bits to get about such a big data sheet. So I'm going to let you guys go through this script. It's on the Moodle. You can use this video as a guide, but I'm also expecting you guys to answer the questions for your tomorrow class. You can partner up if you want to. You can do it individually. There is no need for submission. We'll just have a session next week where you guys can present on what you generated, or if any. I would also implore you to go to the RStudio or GitHub and find other ways to structure your code and not stick to the particular code that's written in here, as long as you can generate the right responses. So I will be leaving this on the Moodle, and unfortunately, because I am in Italy, tomorrow we cannot have class. I look forward to seeing you guys next week. Okay.